Emostel.
Hello, you're welcome again to this video. Right, in this video, we're going to be talking about the straight line graphs. Well, what is it about the straight line graph? What is so special about them? Well, the straight line graph is very important in physics, like I said, and then you are going to discover the importance, topic after topic as we, as those things begin to unravel, okay, one after the other. But now, let me just tell you, this video is just to tell you the general things you need to know about straight line graphs. All right, so join me in this. Let's go. Now, here, the very first thing here says a straight line graph is formed from this equation, y equals mx plus c. All right, don't be surprised then. Let's just quickly check it out. Why is it like that? So if I have, we have a straight line. All right, so let's assume in our mind this stuff are straight, okay? Good. So if I have it this way, this is the origin, all right? And then let's say, okay, this is the y-axis, the x-axis, negative x, negative y, as it is. Okay, right. So looking at this equation which says y is equal to mx plus c. This y here is called the dependent variable. I'll explain why. It's called the dependent variable. And this x here is called the independent variable. Okay? This c here represents the intercept on the y-axis, which means the place where the graph cuts across the y-axis, and then this m here represents the gradient. You can also call it slope. Okay, so I will explain every part of it. All right, so you having something like this. This one is called a dependent variable because every value of y depends on the value of x. When you're dealing with a linear equation, this relationship, this one is called the equation of a straight line. Okay, it can also be called the linear. It can also be called a linear equation. All right, now a linear equation as this. Linear equation because the equation of a straight line, okay? Good. So when you have that kind of equation, let me assume you have something like this. Y is equals to 3x plus 5. Y equals 3x plus 5. What the message that is just being passed here is that y is equal to 3 times any value of x plus 5. It simply means that whatever value of x is, let's say our x is 4. Let's say x is 4. So if we have our x as 4, it means 3 times 4 plus 5. That is what determines the value of y. So 3 times 4 is 12 plus 5. Okay, 12 plus 5 is 17. So which means that when x is 4, y is 17. So if you want to represent this on a graph, on this graph here, then you have it as what? When x is 4, maybe we have something like this. 2, 4, 6, 8, 10, and all. Then let's say this one is 5, 10, 15, 20. Okay, so if you have it this way, when x is, it means that when x is 4, y is what? 17. Because when you slot in 4 as a value here, okay, and then you multiply it by 3 times 4, that's by that coefficient, okay, that's 12 plus 5, 17. It means that the value of y is 17 whenever the value of x is 4. If you change the figure, maybe you say, okay, let's say this time around x is maybe minus 2. If x is minus 2 is somewhere around here, okay? It means that if x is minus 2, y will be equal to 3 times minus 2, then still plus 5. So in that case, we have 3 times 2 is 12, is 6. So we have minus 6 plus 5. Then y will be equal to negative 6 plus 5. It means I'm owing 6 but I have 5. If I pay, then I'll still be owing 1. Okay, minus means owing, plus means having. So we have y is equal to minus 1. So which means that whenever the value of x is, when x is minus 2, y is negative 1. Okay, so we have minus 5, minus 10, minus 15, and so on. Okay, so that's what it means. All right, so if I want to represent this, it means we are working with, let's say, when x is 4, y is 17. When x is minus 2, y is minus 1. Okay, all right, so I'm going to, have to rub this one off so I can explain. All right. Okay. So I'm still coming back to gradient and intercept. Okay. All right. So let's just check this out. When x is 4, this is 4, y is 17. This is 15. 17 should be somewhere around here. Okay. And then 4 goes up and they intersect here. Okay. When x is minus 2, y is minus 1. So minus 1 is somewhere around here. So we have it minus 2, minus 1, then you join it together. So if you have a ruler, a long ruler, then you can connect. You can connect the 2 points, okay? So good. Now, the place where y cuts across where the graph, the line, the straight line, cuts across the y-axis, that is what we call the intercept. The place where it cuts across the y-axis is called the intercept, okay? All right, so now, how do we calculate the slope? The slope of a graph is calculated from any 2 points, okay? So I've told you about y, which is the dependent variable, because it depends on the value of x. Whatever x is what determines what y will be. All right, why we call x the independent variable, because it can assume any value and then y follows it up based on its value. We've told you now that, I told you here now that C is representing the intercept, which is any point where the graph cuts across the y-axis, okay? And then lastly, it remains 1, which is the gradient or the slope. That is what this one represents. The slope is calculated by obtaining any 2 points across the line, okay, wherever any 2 values of x and y intersect. Maybe this is a point for x and y, okay? So let's call this one, let's say point A, and then another point for x and y, let's call it point B, and then you connect the 2 points. That tells you the gradients. Okay, since we have 2 points here, two defined points here that we can play with, so let's just make use of it. So you have this one, draw a line here from this point here, okay? Remember, let's call this one point A, and then at point A, when x is 4, y is 17. And then we call this one point B. At point B, when x is minus 2, y is 1, okay? Then we connect the 2 points, point A and point B, you bring them, you connect them together, okay? So this one here, we can just give it a name. Let's call it the slope triangle. The slope triangle, okay? Now, from this point here to this point, like the bottom of the triangle, we call it the change in x, which is the change in the value of x, okay? X was a value here, and it's another value here. So the difference between these 2 points across the x-axis, the difference between these 2 points across the x-axis is what we call the change in x, all right? Now, the same thing applies here. There is a point here, and there is another point here for y. Y is a particular value here. Y is a particular value here, which is minus 1. When you trace this point to the y-axis, y is a particular value, and it's also another particular value here, which is 17. So the difference between the two values of y is called the change in y. All right? So y was 17 here, okay? And it's minus 1 here. It's minus 1 here. I didn't write the negative, so that's minus 1. Y was 17 here and minus 1 here. Okay, so then that is the change in y. The change in y is the value of y at this point and the value of y at this point. The change in x is the value of x at this point and the value of x at this, and the difference between the value of x at this point and the value of x at this point, that's change in x. So, but then if you look at it with respect to the axis, you will see that, okay, x was 4 here, okay, 2, 4, 6. X was 4 here, and x was minus 2 here. So the difference in the value of x is what we call the change in x. Okay, good. So if you trace this one very well, you see that y was 17 here, okay, and the value of y traced to this point on the y-axis, okay, from here to here, the change in, we have the difference in value of y. So that's what we call the change in y. So slope, the slope is given as the change in y over the change in x, okay? Which means that the value of x at the new point minus the value of y at the new point minus the value of y at the initial point divided by the value of y of x at the new point minus the value of x at the initial point, okay? Remember that at this point, this is the initial point, this is the new point. So we call it the first point, point A, the second point, point B, and then we use it to calculate the slope. And that any answer we get from there, that is what this M represents. So M represents the slope of the graph. Okay? It is very plain, it is very practical. Very, very practical. So if you have a graph like this, maybe you have an equation like this, y equals 3x plus 2. Okay? Without you plotting the graph at all, without you even having to plot the graph, you from the picture of the equation, you can always tell that the slope of the graph is equal to 3, while the intercept, okay, is what? Is 2. You can easily tell. And truly, if you plot this graph, you actually plot it, you choose different values of x to get different values of y, and you use it to plot the values of x and y, you use it to plot a straight line graph, okay? You will see that if you are drawing it on a real graph book that has all the lines, all the web lines on it, okay, you will see that truly if you plot that graph, the graph will genuinely cut across the y-axis at point 2. And if you find the slope using any 2 points across the line, any 2 points across the line, even though you pick it from here and here, as far as the 2 points are on the straight line graph, and you can get the value of x and y at each point, you will still get your slope, okay? So that's it. So you will see that the slope of the graph, truly and truly, when you plot it, you are going to get 3. So if you have a graph book at home, I want you to try it, okay? Just look for different values of x and then the corresponding values of y, plot a graph, and then you will see that truly the graph will cut the y-axis as 2, and the slope of the graph, when you calculate it, will be 3. Mathematics never lies. Okay, now, like I told you, there's something I've not told you about slope. The slope of a straight line graph is always constant. The value does not change, regardless of where you pick the stuff from, where you pick the 2 points from, the value does not change. Okay, so which means that even though I pick the 2 points A and point B, and I check the value of x here and x here, y here and y here, and I use this formula and I derive the slope, even if I choose it from another point, I am still going to get the same value for slope. The value of slope for any straight line graph is always constant. It doesn't determine where you pick the point from. It's not because I picked the 2 points from here and I also picked the 2, and I picked the 2 points from somewhere else and I got different results. No way. You are going to get the same result. The change in y with respect to the change in x is constant across all points of a straight line. But this is not true for a curve, although we are still going to curves. Okay? So that is that as per that. So which means if we are to calculate the slope of this particular graph here that we have here, so we are just going to say that m is equal to, using this equation, y2 minus y1, x2 minus x1. Okay, so let me just pick the values here as the values of 1, and then the value here as that one of the 2's. Okay, so we are going to take is y2. Okay, remember that the first value is always the value of x, the second one is always the value of y. Here too, the first one is always x, the second one is always y. When you switch them, you mean something else in mathematics, okay? So if I say 17, 4, it means I am telling you that x is 17, y is 4. So you don't just write them anyhow. The position is very significant. So we move. So let's say y2, let's pick our y2 from here. Let's assume we pick our y2 from here. That's minus 1. Then minus y1. y1 is 17, positive 17, okay? Divided by x2. So we are picking our x2 from here, which is minus 2. Then minus y2, which is y1 rather, which is 4, okay? So then we are going to have minus 1 minus 17. It means I'm owing 1 and I'm owing 17. Altogether, I'm owing 18. Then minus 2 minus 4 means I owe 2 and I owe 4. Then altogether, I'm still owing 6. So according to mathematics, minus divided by minus is plus. Well, you can just simply say minus cancels minus. Then 6 here 1, 6 in 18 is 3. So which means that the slope m is equal to 3. The slope of the graph is 3. You understand? And so that's how it goes. So we have gotten the slope as 3, and then and that's that as per that. If I want to get the equation of the straight line back, the equation I used to produce this graph, since I know the value of the slope, okay, I could just if I was using a real graph, then I would know the intercept, then I can just slot it in, and then I'll get the equation of that line. All right. So, well, if I can still get it if I want to, since I know that y is equal to mx plus c, even if I don't know the intercept yet. So what I'm going to do now is that if I want to find the intercept mathematically, I'll pick any two values of any value of x and y at the corresponding point. So at this point, what is x? At this point, x is 4. So, and y is 17. So I will say 17 is equal to the slope I just got, which is 3, multiplied by x value at that same point, which is 4, then plus c. So if I have it that way, 3 times 4 is 12, okay? So I will have 17 is equal to 12 plus c. It means my c is equal to 17 minus 12. So c is equal to 5, okay? So which means the intercept is 17 minus 12, yeah. It means the intercept is 5. You know, this graph, I did not, it's not accurate because I just used any value of, I didn't use this thing specifically like that. It's not an accurate line. So if the lines were accurate, then you would have gotten the value of this place as 5 if you plot it on a normal graph. Okay, so this is just a random position because I did not use any graph book. If you use the graph book to form this, you will see that truly the line will cut at the point 5 on the y-axis. Okay, so that's it. So, which means the original equation is y is equal to slope, which is 3, then x plus the intercept 5. So that is it. So which means this is the equation that produced this graph, because the intercept is 5, as we just calculated, then the slope is 3, as we obtained, okay, and then we have this. So don't let this use you. And so that was that as per that. All right, so we've talked about a few things. Now, to wrap it up, let's just talk about a few more properties of a straight line graph to wrap it off. Okay, I've told you that regardless of where we pick the stuff from, we are still going to get the same answer for the slope. So that one is sealed. Then the thing I didn't tell you earlier is that slopes can be of, can be a negative, we can have negative slope or positive slope. But then before we go on to that, let me just quickly tell you that it doesn't matter where I picked these guys from, the one I want to use as 1 or the one I want to use as 2, you are still going to get the same answer. which means if, for instance, you know, I picked my x1 and y1 from here, x2 and y2 from here. If I swap it and say, okay, I want to pick my x1 and y1 from here, my x2 and y2 from here, no problem. Let's go. x2, you know, the formula says y2 minus y1 divided by x2 minus x1. So y2, now let's say we picked our 2's from here and our 1's from here. So y2 will be 17, then minus y1 here, which is minus 1, okay, divided by x2, which is 4, minus the x2 here, x1 here, which is minus 2. So if we do like that, we have 17, minus times minus is plus, then we have 4, minus times minus again plus, then 2, okay? So at the end of the day, we have 17 plus 1, which is 18, then 4 plus 2, that's 6, okay? So 6 here, 1, 6 in 18 is 3. And so the answer for M still remains the same 3, despite the fact that we chose our 2's from and our 1's from different places. All right? So that's that, as per that. Now, talking about the two kinds of slope that we can have. Yeah, the two possible kinds of slope to have on the straight line graph is negative slope and the positive slope. Okay? Now, let's say we have our graph like this. If the graph goes upward, okay, it goes like this, it goes upward like something that is elevating, then this graph is going to have a positive slope, okay? It's definitely going to have a positive slope, regardless of where you picked your x's and your 1's and your 2's from. The slope of this kind of graph will be positive because it goes upward. But if you have a graph like this, and then it goes this way, it goes this way. You know, this one elevates. Why this one what? It depreciates. Okay, if your graph goes in this direction, this one goes upward. If your graph goes, slopes downward like this, then it means the slope is going to be what? Negative. The slope is definitely going to be negative here, in this place, okay? So just like we can have a negative slope and a positive slope, we can also have a negative and a positive intercept. Likewise, look at the intercept here. The place the stuff cuts across the y-axis here is negative. So C is negative here because it cuts across the y-axis at the negative value of y. And then C is positive here because it cuts across the y-axis at the positive value of y. So, however, the slope and the intercepts are not that, the slope does not, the negativity of the, or the positivity of the slope does not determine the negativity or the positivity of the intercept. Sometimes we'll have a positive slope and a negative intercept, just like what we have here. In the example we had before, we had a positive slope and yet also a positive intercept. Okay, so it doesn't matter whether because the intercept is negative, then the slope will be negative or positive. No, so they are independent. Okay, so the slope in a particular condition, in a particular equation can be negative, and then the intercept is positive. No problem. Okay, but the thing is just that, just as we can have negative slope and positive slope, we could also have negative and positive intercept. It all depends on. For the intercept, it depends on where the graph cuts across the y-axis, and then for the slope, it depends on the direction of the graph. So let's just try to look for a, let me just try to show a case where we have the negative slope. So let's say we have a graph. Maybe this place is 10. This place is 10. This place is let's say 5, and then we have it this way, okay? And then let's say okay, I beg your pardon. All right, so let's say we have a situation like this. This is -1, -2, -3, this is 0, sorry, 1, then we have 2, we have 3, okay? And then let's say we have 5, 10, 15, this is -5, -10. Remember that these are approximate position because I'm not using a graph, a real graph. So, okay, so let's say we have, let's say y is 10 when x is minus 2. Y is 10 when x is minus 2. And then we have, let's say y is, let's say x is 3 and y is minus 10. Okay, or let me just still use 2 and stuff like that. So let's say here, y is 2, x is 2, and then y is minus 10. Let me just choose these 2 points. Okay, good. So let's say we drew the line, and then it happens like this. Okay, good. You see, at this point, x is minus 2 and y is 10. But at this point, let's call this point A. At point B, x is 2 and y is minus 10. Okay? Now, the slope is going to be changing y over changing x, right? Which is y2 minus y1 over x2 minus x1, right? So now, y2, we can pick it from anywhere, but just know that the same place you pick your y2 from, that is the same place you pick your x2 from. The place you pick your y1 from, that's the same place you pick your x1 from. But it doesn't matter where you pick this from, either this coordinate or this coordinate, but anywhere you pick y1 from, that's the same place you must pick your x1 from. So I'm picking my y1 from here. Okay, I'm picking my y1 from here. So I'm going to pick my x1 from here too. So this one will be x1, y1. This is like x2, y2. So at the end of the day, we have, so y2 is minus 10, then minus y1, which is positive 10, then divided by x2, which is 2, minus, okay, minus x1, which is negative 2. Okay, the value of x here is negative 2. So at the end of the day, I owe 10 and I owe another 10. Altogether, I'm owing 20. Then I have 2, okay, minus times minus is plus. Minus times minus becomes plus. So 2 plus 2 is 4. So at the end of the day, the slope is going to be equal to what? The slope is going to be equal to 5. Okay, so that's negative 5. Because 4 here, minus divided by positive, we give minus. Okay, so then 20 divided by 4 is 5. So which means the slope is negative 5. You see, m is equal to minus 5. All right, so since the slope is negative 5, if we want to even generate the equation that causes this line, let's generate it. Now the equation of a straight line is y is equal to mx plus c. Okay, good. So in this case now, let's pick any value of y, Let's say, okay, the value of y here is 10. Then the corresponding value of x at that point is minus 2, right? But the slope is minus 5. Minus 5 times minus 2 plus c. Okay, so x is minus 2 at this point, and then y is 10 at that same point. Anywhere you pick x from is where you pick y from. If I decide to use this one too, it should be like that. Okay, so at the end of the day, I want to generate the equation that from this line. Okay, just from the graph. So we have it as 10 is equal to minus times minus is plus. Okay, 5 times 2 is 10, then plus c. Okay, at the end of the day, we have, let's take this one to the other side. We have 10, as this 10 goes to the other side, it becomes negative. So it was positive before, it goes to the other side, it becomes negative. Or you can say subtract 10 from both sides, just to make c to stand alone. So we have c. So at the end of the day, 10 minus 10 is 0. So which means the intercept is what? Is 0. So therefore, the equation of the line is what? Y is equal to m, which is our slope. Our slope is minus 5. Mx plus what? Our intercept is what? Is 0. Okay, good. So, or you can just say y is equal to minus 5x. This is the equation of the graph, of the line that produces this graph. The slope is negative, and then the intercept is 0. As you can see, even despite the fact that it was a sketch, okay, the graph still shows that it passed through what? The intercept 0, despite being a sketch. Do you understand? So I think I tried to be as straight as I could in this case. and I try to manage the position. Well, look. All right, so for whenever you have y is equal to mx, like whenever you have y equals to mx and the c is not there, it simply shows that that graph, okay, it simply shows that it is a straight line graph that passed through the origin. It means it's a straight line graph, a linear graph, that's what? That passed through the origin. It passes through the origin. So any graph that has an intercept at 0, it means it cuts across the y-axis at point 0. It means that graph passed through the origin, because when x is 0, y is always 0 too. Okay? At the origin. At the origin, x and y are both 0. So that is that aspect. So which means if you have a graph like this, it means the graph has an intercept. But if you have the equation like this, it means that the graph has the intercept is 0, which means it passed through the origin. Okay? So that's that. So which means from the structure of the graph, you can really determine so many things. You can understand so many scenarios. You can get so many events. Just by looking at the equation, you can say a lot of things about the graph. Okay, like you can see, by looking at the equation, you will know that this graph has a negative slope. By looking at the equation, you will know that this graph passed through the origin. Do you understand? So the states of the graph or the equation can tell you a few things about the graph. Looking at this, the other one that we have the other time too, by looking at the graph, you will know that the graph cuts across, by looking at the equation, you will know that the graph cuts across the y-axis at 0.5. So all of these things concerning the equation tells you a lot of things about the graph. And that is also how we interpret physical terms too, using graph. And that's the reason why you even have to learn about graph before you go into the practical proper. Do you understand me? So you are learning about this graph because you can, if you can understand the characteristics of the graph and interpret some things about the graph from the equation, you can also be able to interpret physical events using the equation of that that's the graph formed from that practical. Okay, we are going to get there anyway. So at the end of the day, we've been able to discuss a few things. I told you we talked about the straight line. Sorry, my alarm. We talked about the equation of a line, of a straight line, and then we discussed the gradients. We also talked about the slope having tendency of being negative or positive, and we talked about the intercept, okay, and as it points across the y-axis, and then the fact that the intercept can also pass through the origin and can also be positive and negative. So we've learned a lot concerning straight line graph. All right, so in the next video, we are going to be talking about the nonlinear graph. Okay, see you there. Bye.